So we've got two first order differential equations here. This one here is linear. This one here is non-linear with this squared term here. And what we're going to do is we're going to look at the kind of solutions you get when you solve these functions in terms of undefined places on the result. So for example, there will be parts on there which have singularities. And we're going to try and define those singularities and see which kinds they have. So I've got here 2 times dy dx equals y of x squared, and dy dx plus 2y over x equals 0. Now I'll set the boundary condition for both as y of 2 equals k. So that's a condition for both of them where k is an integer. Okay, so first of all, let's go in and try and solve these equations. So I've got 2 dy dx equals y of x squared. Well, I want to get my y's on this side for a start. So let's divide both sides by this y of x squared. So I've got 2 times dy dx over y of x squared, and that will equal 1, dividing both sides by y of x squared. Okay, now what I want to do is try and integrate both sides with regards to x. That's the standard way to try and solve these equations. So this one with the dx and this one dx. Okay, this side, no problem, we go straight into that if we like. This side is a little bit untidy, so let's just try and tidy that up a little bit. So the 2 can come out front, leave the integral sign. It's still going to make a fraction, so my y of x squared will stay there. And we still need to integrate with regards to x, so my dx can go here. And here I've got dy dx. That's the last bit I need to sort out. So my dy will stay on top, and this dx will go on the bottom. And then set that equal to this much simpler integral on the right hand side. Okay, well, we can cancel something out now to try and get straightforward on this integral here, and then we can integrate on this one. So these will cancel out, and now we're ready to integrate. So here we've got 2 times, let's write this out a little bit clearer. We'll have 1 over y of x squared and then dy, and that equals 1 dx. So now if we integrate this with regards to y, I'm not going to get a logarithm here, I'm going to have a power rule situation. So now I'm going to have 2 times, so a power rule situation here, y of x squared, I'm going to have minus 1 over y of x, and then no constant of integration, and then this side I'm going to set it to equal to x, that's a straightforward integral there, and some constant c1 for the purpose of this question. So now I need to just simplify this off a little bit and try and get my y of x isolated. So my 2 I can just bring inside, so I've got minus 2 over y of x equals x plus c1. Okay, so now all I need to do now is bring this over to this side and set it equal to my y of x. So let's bring that up to the top. Okay, so that's, as we said before, we'll just bring this x plus c1 over this side, x plus c1, and then that equals my y of x. So that's my general solution. I'm going to put my condition here in after I've solved this one. Okay, let's solve this one. So I've got dy dx, that's fine. 2y over x, I want to get my x over here. So let's try and do that. So now I've got dy over dx equals minus 2y over x. So that's all fully legitimate transformation of that equation. I want my y on this side, but my x can stay here. So I'm going to leave the minus 2 over this side as well. So now I'm going to have dy over dx divided by my y, and then that will equal minus 2 over x. Okay, so as we did on this side, I'm now going to integrate both sides with regards to x. So a nice big integral there and a dx, and a nice big integral there, dx. Okay, so this side I can tidy this up no problem. this side I need to just fiddle around with this a little bit. So now I'm going to get my integral. Well, y will stay on the bottom, and with regards to x, my integral parameter there, set that. And then dy dx. So dy will stay on the top, and I'll have my dx on the bottom. And then here, I'm going to bring my -2 out front. That'll leave me with 1 over x dx. Nice easy integral on the right hand side. Okay, well, as before, these dx's are going to cancel out, and now I'm going to be left with the integral of 1 over y equals -2 times the integral of 1 over x dx. And now we're ready to integrate. So I'm going to bring these up the top and do my integral. Okay, so let's get this integral sorted out. 1 over y, that's a straightforward integral with regards to y. That's just going to leave me with natural log of y. And here, natural log again, and multiplied by -2. So -2 times natural log of x. So this is where I put my constant of integration in. So this time, as I've already used C1, I'm going to now use C2. Okay, so now we need to get y of x on its own. So now I need to do the exponential on each side just to try and cancel out my natural logarithms. So exponential and natural logarithm, inverse functions. So straight away my y, I can now put it in as my function. Y of x equals, now e to the -2 ln of x. Now I've got to be a little bit careful with this and this bit here. This -2 here is not going to be multiplied by my x when I cancel out my natural logarithm. This -2, using the logarithm rules, will now be multiplied by my x, as in the power of x. So now I'm going to have that equals x to the -2. So that'll be the power of x, not multiplied. And then here, as it's got addition here, using the indices laws, this is now going to be multiplied by e to the c2. So then this will simplify off to my y of x equals e to the c2 over x squared. Now just deal with this a little bit. That's still a little bit untidy. You could leave it as that if you wish. But I'm now going to set this as a new constant because c2, I don't know what it is yet. I can set that to a new constant, call that c3. So that equals c3 over x squared. Okay, so I'm going to put these two results now back up the top, and I'm going to find what they are worth with my y of 2 equals k with that initial condition there. Okay, let's clear off the board. Okay, so now let's put this condition in there. Y of 2 equals k. So where we see an x, we plug in a 2, and y of x will equal k. So let's plug that in for this one. So therefore y of x is k, so now I've got k equals -2 over x is 2 plus c1. Now I need to try and get this c1 on its own. So now change places with these two. So now I'm going to get 2 plus c1 equals -2 over k. And now subtract 2 from both sides. c1 is all on its own. Okay, now let's just factor this one out a little bit. So now I can have c1 equals -2 times 1 over k plus 1. So that's my value of c1. So let's write that on here. So -2, 1 over k plus 1. So that takes care of my c1. Now let's look at c3. Well, c3 is going to be a little bit more straightforward. So c3 over x squared equals y of x. So now I've got y of x equals k. c3 I don't know, that's what I want. X squared, well my x is 2, so that's over 4. So now c3 equals 4k. So let's write that value here. Okay, let's just clean these off the board a little bit, and then let's go through our values here and find our singularities. Okay, so that's my solutions there sorted out, and I've got my C1 and my C3 calculated for this condition here, y of 2 equals k. Now here I've got C3 equals 4k. So let's write that with that value in there. So I've got 4k over x squared is my y of x with my condition. Now here, whatever value of k is, that's not going to make this function undefined. My only undefined point is where x equals 0. So x does not equal 0. So this is what's called a fixed singularity. So this is a fixed singularity. So any value of k will not affect where the singularity is. So that's what makes this one a fixed singularity. Now what about this one? Let's plug in my C1 here. Now my C1 here is minus 2 times 1 over k plus 1. So let's write that in there now. Y of x equals minus 2 over x, and now minus 2 times 1 over k plus 1. Now here, my k could be any value. It's an integer, so we don't know what that is yet. So this k could be anything. So what I don't want is for my x to equal 2 times 1 over k plus 1. If my x is that value, then this term on the bottom would become 0. So there could be different values of k where this is undefined. For example, if k equals 5, I don't want my x to equal 2 times 1 over 5 plus 1. So that's going to be 2/5 plus 2. So therefore that's going to leave me with 12 over 5. I don't want my x to equal 12 over 5. That's what I don't want. So if x is 12 over 5 and k equals 5, this will give us a singularity. And there's other values of k which you can go through. So this is what's called a movable singularity. So, and this one's a fixed singularity. So this one could be for different values of our k. This one here, it doesn't matter what k is, it's only when x equals 0. So that's the difference between fixed and movable singularities.